1 students, if alpha and beta are zeros of the polynomial p of x is equal to x square minus 2x minus 1, then find the value of 1 upon 2 alpha plus 1 upon 2 beta plus 3 alpha beta. Okay, so let us see how can we solve it. First we write the polynomial, given polynomial, and that given polynomial is p of x is equal to x square minus 2x minus 1. Okay, so as usual we write x square minus 2x minus 1 is equal to 0. So now this is the quadratic equation and we compare these quadratic equations with the general form of the quadratic equation, that is ax square plus bx plus c is equal to 0. Then we have a is equal to 1, b is equal to minus 2 and c is equal to minus 1. Okay, so now here given that is the alpha and beta are the zeros of the polynomial. So here we can say that alpha plus beta is equal to minus b upon a and alpha multiply beta is equal to c upon a. So that means the alpha plus beta is equal to minus of minus 2 and a is that is a 1. So here alpha plus beta is equal to positive 2. Okay, that means the 2. That means only 2. And here alpha beta, that is c means minus 1 and here 1. So here alpha beta is equal to minus 1. So now we have the two values alpha beta and alpha plus beta, and we want to find out the value of this one, that is the 1 upon 2 alpha plus 1 upon 2 beta plus 3 alpha beta. Okay, 3 alpha beta. How can we find out? First we simplify this. Okay, first we simplify, that is I only do the addition of these two. Okay, so 2 beta cross multiplication, 2 beta plus 2 alpha upon 2 alpha multiply 2 beta plus 3 alpha beta. So that's why common from these two, that is the 2 in the bracket beta plus alpha, and here 2 alpha multiply 2 beta plus 3 alpha beta. So now here students, the 2 get cancelled and then we have that beta plus alpha means alpha plus beta, and then 2 multiply alpha beta and here that plus 3 alpha beta. Okay student, so now here that we can substitute the values, the given that values, that alpha plus beta, that is the 2. So here 2. Now here 2 alpha beta is the minus 1 and plus 3 multiply alpha beta minus 1. Okay students, and then here that 2 get cancelled, then here minus 1 upon minus 1. 1 upon minus 1 students, and here minus 3. So here minus 1 upon minus 1 means minus 1 and here plus or minus 3, that is a minus 3. So that means equal to minus 4. So here our answer, that is a 1 upon 2 alpha plus 1 upon 2 beta plus 3 alpha beta is equal to minus 4 student. This is equal to minus 4. And if alpha and beta are the zeros of the polynomial p of y is equal to y square minus 5y plus 3, then find the value of alpha raised to 4 beta cube plus alpha cube beta raised to 4. So let us see, first find out, that is the first write down the polynomial, that given polynomial is p of y is equal to y square minus 5y plus 3. Now here alpha and beta are the zeros of the polynomial, that means this y square minus 5y plus 3 is equal to 0, which is in the quadratic form, and that means we compare this equation with the general form of the quadratic equation ax square plus bx plus c is equal to 0. So that means a is equal to 1, b is equal to minus 5, and here student c is equal to 3. So now the alpha and beta are the zeros of the polynomial, students. Okay, so here alpha plus beta by the formula minus b upon a. So the alpha plus beta is equal to minus of minus 5 upon 1, and that means alpha plus beta is equal to 5, students. Okay, alpha plus beta is equal to 5. Now alpha beta as per the formula c upon a. So alpha beta is equal to 3 upon 1, and that means alpha beta, here alpha beta is equal to 3. Okay, now we are ready to find out the value of this one, that is alpha raised to 4 multiply beta cube plus alpha cube multiply beta raised to 4. Okay, so now here see carefully, student, that from these two terms the alpha cube beta cube are the common, and in the bracket alpha plus beta. Okay, now here alpha cube beta cube we write is in the cube form, that is alpha beta whole bracket cube, and here alpha plus beta. Now here we have the value of alpha beta, and that is equal to 3. So cube of 3 here, and alpha plus beta, that is the 5. Okay, so here cube of 3, students, that is a cube of 3, 3 3s are 9, 27. So 27 multiply 5. Okay, so 27 multiply 5, and that means 135. Okay, so here this way alpha raised to 4 beta cube plus alpha cube beta raised to 4 is equal to 135. Now the question 12, students, that is if the zeros of the polynomial x square plus ax plus b are in the ratio 3:4, then prove that 12a square is equal to 49b. Here, students, the given polynomial is p of x is equal to x square plus ax plus b. Okay, students, and we write it is in the quadratic form, that is x square plus ax plus b is equal to 0. Okay, so now here compare this equation, this quadratic equation, with the general form of the quadratic equation ax square plus bx plus c is equal to 0. Then we have a is equal to 1, b is equal to a, and the c is equal to b. Okay, so now here the given is that the zeros of the polynomial are in the ratio 3:4. Okay, so here I write the zeros of the polynomial, are in ratio 3:4. Okay, 3:4. So now here if you consider that alpha and beta are the two zeros of the given polynomial, okay, then alpha is equal to, that alpha will be 3x and beta will be the 4x. Okay, because the ratio is 3:4. So here we can say that the multiple of the ratio, that is the multiple of ratio bx, so that means alpha is equal to 3x and beta is equal to 2x. Okay, and then here alpha plus beta is equal to minus b upon a. Okay, and alpha multiply beta is equal to c upon a here. So now alpha plus beta, that means 3x plus 4x, which is equal to minus a upon 1, and that means 7x is equal to minus a here. And the alpha beta, students, that alpha beta, that means 3x multiply 4x is equal to c. C means the b and a means the 1, that means b upon 1. So that means that 12x square is equal to b. So now here 12x square is equal to b. Now here that we have to prove that 12a square is equal to 49b here. Okay, so here right here that x is equal to minus a upon 7. X is equal to minus a upon 7. Now this value substitute in this equation. So here 12x square is equal to b, and that means 12. At the place of x I write here minus a upon 7 whole bracket square is equal to b. So that means 12 multiply a square upon 49. Okay, so now here is equal to b. That means 12a square is equal to 49b. Okay, now here see student, that was our to prove. Okay, next one example, students. Find the zeros of the polynomial p of x is equal to 3x square minus 4x minus 4. Hence write a polynomial whose each of the zeros is 2 more than the zeros of p of x. So now here students, that first we write the given polynomial, and the given polynomial is p of x is equal to 3x square minus 4x minus 4. Okay, student, so as usual we write 3x square minus 4x minus 4 is equal to 0 in the quadratic form, and then we solve this, that we want such a two number that having the product minus 12 and the addition or subtraction will be the minus 4, students. So such a way the two numbers are 6 and 2, that means minus 6 plus 2. So here I write 3x square minus 6x plus 2x minus 4 is equal to 0. That means here 3 multiply x minus 3 multiply 2 multiply x plus 2 multiply x minus 2 multiply 2 is equal to 0. That means the common from these two terms are 3x. So 3x in the bracket x minus 2. From these two terms the common is 2, and in the bracket we write x minus 2 is equal to 0, students. So now here in the first bracket we have x minus 2, in the second bracket 3x plus 2 which is equal to 0. That means x minus 2 is equal to 0, or we can say the second bracket 3x plus 2 is equal to 0, students. So x is equal to 2 and the 3x is equal to minus 2. So x is equal to minus 2 upon 3. So now we can say that the 2 and minus 2 upon 3 are the zeros of the polynomial, are the zeros of the given polynomial. Okay, given polynomial. And then here, so the first part is over, student. Then the next part, that is write a polynomial whose each of the zeros is 2. Zeros 2 is 2 more than the zeros of polynomial x. Okay, so now here we consider that here let alpha and beta are the zeros of the zeros of the new polynomial. Okay? New polynomial. That means students, alpha is equal to the 2. Original one is 2, then more than 2. That means alpha is equal to 4. And then beta is equal to, that is minus 2 upon 3 original one, and more than 2, that means beta is equal to minus 2 plus 6 upon 3, which is equal to 4 upon 3. So here beta is equal to minus 4 upon 3. So now here the 4 and 4 upon 3 are the zeros of the new polynomial. And so now here our polynomial becomes, what is our polynomial? The format is x square minus alpha plus beta multiplied x plus alpha beta is equal to 0. That means x square minus alpha plus beta, that is 4 plus 4 upon 3 x plus alpha beta, that is the 4 multiply 4 upon 3 is equal to 0. That means here x square minus, that means 12 plus 4 upon 3 multiply x plus 16 upon 3 is equal to 0, and the final answer is x square minus 16 upon 3x minus plus 16 upon 3 is equal to 0. So such a way we have the quadratic form, that is the polynomial is x square minus 16 upon 3x plus 16 upon 3 is equal to 0. Students, thank you for watching our videos. Achieve your success with us. I am sure that you will get 100% success in maths. So watch our videos continuously, regularly. Like our videos, share our videos to your friends, and